Okay, now we're going to be looking at solving systems of equations, but we're not doing it by graphing. So there's actually two methods to do this. One of them is elimination and the other one is substitution. The one we're looking at right now is substitution. And that's the one that will always work. Elimination sometimes doesn't work, which is why I'm not going over it right now. So substitution. So we can solve a system of equations without using a graph using algebra. Obviously you already know or should already know how to solve things with one variable, like 2x plus 3 equals 7. There's only one variable there, one unknown, that's the x. And so what happens when now there's two unknowns? There's an x and a y. Well, we can't really solve it just normally, but with a system we're allowed to use another method to eliminate or to remove one of those variables. And so the idea here is that we're going to take a two variable, so an x and a y, but it's going to be a system. So there's two equations, and we're going to turn it into one variable. And once you do that, we can then solve. So we somehow have to get these two variables into one variable. And this is really important here. Reformulating an equation to y equals, to equal y, is really helpful. So you're going to see that here in the first example, they were already done for you. But these two, they're not y equals. So those are going to require some work. So let's take a look here. Once you have them y equals, you can now eliminate one of the variables or one of the unknowns. And to do that, it's interesting, but you're going to say, well, y, this y, the top one, equals this. Y is equal to that. But there's also a y down here. So what we're going to do is we're going to say, well, this is y. It says it. Y equals this. So this is what y is, so we're going to throw it into here, because this is y. So what we basically are doing here is we have two equations, and we're going to set. We're going to set y is equal to y. Now, y equals y. Again, we're going to do a bunch of examples, so don't worry too much about this. Just kind of watch here. But y equals y. You know that's a true statement. Like 4 equals 4, that's true. Y equals y, those are the same letters, that's true. Now, one of the y's is the left one, so negative 2 over 5x plus 16 over 5, and the right y could be the other one, 4x minus 10. Okay, so whenever you have these, and often they'll have fractions, so this is going to be over 1 over 1. We're going to want to get a common denominator. Notice it, by the way, that this thing only has x's. The y's have been completely eliminated. So we should be able to solve this. This is a question that looks maybe a little intimidating because it's got fractions, but it'll actually be quite simple once you see how we get rid of them. So I'm going to get a common denominator here. So we'll times this by 5, and that by 5. We'll times this by 5, and we'll times that by 5. And so we've got a negative 2 over 5x plus 16 over 5 equals 4 times 5 is 20. So 20x over 5 minus 50 over 5. And once you have all of them, then you can do the 5s are on the denominator. You can multiply the numerator by 5, so up top, and whatever you do to one side, you also have to do the other. And this 5 is going to go into both of those, so the 5 on the numerator will cancel with the denominator, and then when it goes into here, it will also cancel with that one. And then this 5 here will cancel with that 5 and that 5. So then what you're left with is negative 2x plus 16 equals 20x minus 50. And that question is a pretty simple algebra question at this point. Now, I always move over the x's first. Well, actually, first thing I do is see is any on the left. Is there any like terms? Nope. On the right, are there any like terms? Nope. So then what I do is I move the smaller or more negative x. That's just the way that I do it. So I'm going to move this 2x because it's negative, and this is a 20, so the negative 2x is more negative. And I'll add it over to here. So I get 16 equals 20 plus 2 is 22x minus 50. And then I can add 50 and add 50. So I get 22x, 50 is 66. And then I can divide by 22. Divide by 22. And 66 over 22 is 3. Okay, so I have just found that x is equal to 3. The problem is that, if you remember our last chapter, we need an x and a y. And we have now found the x is 3, but we don't know what the y is. So, to find the y, and that's why you can take a look at this page here, there's so much room here because there's a lot of work going into this. To find the y, you can choose whatever equation is easier. So, the top or the bottom. Now, I'm going to choose the bottom because the bottom is doesn't have any fractions in it. So, y equals 4x minus 10. So now, to find y. And this is choose an equation. Which one? Doesn't matter. But I'm going to do the 4x minus 10. And I know that, the x is 3. We just found it. And then I can just finish up here. 4 times 3 is 12 minus 10. And 12 minus 10 is 2. So we can put a little therefore here. Therefore, our point is 3, 2. I don't think I have that. Yeah. So that's how you do that. Now you could have done the other equation, which is, I don't know, 2 over 5 negative. So you have negative 2 over 5 times the 3, x is 3, plus 16 over 5. And this is a denominator of 1. So 2 times 3 is negative 6. 5 times 1 is 5. Plus 16 over 5. And I'm just scribbling here. Negative, these are already common denominators, so you can add them together. It's negative 6 plus 16 is 10. And 10 over 5 is 2. So either way you'll get 2. It's just that this one had a bunch of fractions in it. It was a little bit more complicated, so I didn't choose it. But you could have, and you would have got the same answer. Okay, so that is that. We have found the solution. And I think I'll stop the video there, and I'll make the next video where we can do these two. I'll probably start with this one because it already is y equals, but maybe I won't. We'll see.